Hi everybody, it's Mrs. Kroll. I'm just going to go over the stations from 3.3. Most of them are 3.3 stations. There are a couple review ones in here, but I'm just going to go through all of the stations. There are 8 of them, so feel free to skip ahead in the video or pause the video wherever you need at any station. Okay, first one, number 1. The first thing that we have is a table here. So the table above gives the values of the differentiable functions f and g and f prime at selected values of x. And then it gives us this piece right here. And this piece is really important. G of x is equal to f inverse of x. So we know that g would be the inverse of f of x. So as we start this problem, we know that we're looking for g prime of 4, and so 4 is the x value of my inverse, meaning that it's going to be the y value on my function. So as we take these derivatives of inverses, remember that you're going to set 4 equal to the function, and we're going to solve. So I'm going to look down my f of x column for my answer of 4. And when I get for my answer of 4, I can look back, and my x is -2. And so we're going to use this row then to help us solve the rest of the questions. So now I want to find f prime of -2, which I can do by looking in this row. F prime of -2 is going to take me to 4. And then finally, remember, step 3 is always flip. So flipping the 4 is going to give me 1/4. Answer is D. All right, station number 2, we're trying to find f prime of 2. This is not an inverse one. This is a regular function problem. So I'm going to take the derivative of the function. Bring down the -2, so we have -8 x to the -3rd power plus bringing down the 2 times 1/4 is 1/2 x to the 1 less power, and the derivative of 4 is 0. And then we are going to take 2 and we are going to plug it in here to f prime. So I have -8 over 2 cubed plus 1/2 times 2. 2 cubed is 8, so -8 over 8 is going to be -1 plus 1/2 times 2 is 1. So I get an answer of 0, which is D. Station 3. Let the function be defined. F of x is equal to x cubed plus 1, where we know that g of x is equal to the inverse of f of x. What is the value of g prime of 2? Oh, I missed over this part. We also know, and this is going to be helpful, that g of 2 is equal to 1. So that's on the inverse. So let's go through our steps again. We know that 2 is the x value on the inverse. So that means it's going to be the y value on the function. And now we look at this and we're going to say, well, how are we going to solve this without our calculator? Well, that's where this piece comes in here. We know that g of 2 is equal to 1. So this is my x value on my inverse and my y value on my inverse, which means that the ordered pair on my function would be switched. It's going to be 1, 2. So my x value is going to be 1. Then we're going to take the derivative of f of x, 3x squared plus 1, and we're going to plug in 1 into that derivative. 3 times 1 squared plus 1. 1 squared is 1 times 3, and then plus 1 is 4. Final answer, always, step number 3, is to flip. So flip the 4, and we get an answer of 1/4, B. All right, this next one, we want f of x equals x times g of h of x. We are trying to find g prime of 3. We have a bunch of information that we'll be using to help us out. So the first thing we gotta do is find f prime. So when I find f prime of x, I see that it is going to be product rule. And while I'm doing my product rule, I have my first as x and my last as g of f of x. So that is going to be chain rule. So first, derivative of the last, and that's chain. So derivative of the outside, copy paste the inside, times the derivative of the inside, plus last, derivative of our first, well, the derivative of x is 1. That's gone. And then we're trying to find f of 3, f prime of 3. So I'm going to take 3 and plug it in for every x value that I see. I'm going to start by solving these composites first. I want this h of 3 and this h of 3. So that I have f prime of 3 is equal to 3 g prime of, now h of 3 is right here, that's 4. So g prime of 4 times h prime of 3 plus g of 4. All right, let's go plug all the rest of these in. So f prime of 3 is 3 times g prime of 4. G prime of 4 is 3 times h prime of 3. H prime of 3 is negative 2 plus g of 4, and g of 4 is 2. So 3 times 3 is 9 times negative 2. It's going to be negative 18 plus 2. And we get an answer of B, negative 16. All right, moving on to station 5. Again, we have f of x is a differentiable function such that f of 3 is 15, f of 6 is 3, f prime of 3 is negative 8, and f prime of 6 is negative 2. The functions is differentiable, and we know that g of x is equal to f inverse of x. So we know g is the inverse. So we're trying to find g prime of 3. So we'll run through our steps again. Step number 1 is we're going to set 3 equal to my function of f of x. 3 being the x value on the inverse means it's the y on the function. And so my x value, where is my f of x equal to 3? That happens right here at f of 6. So my x value is 6. Then we're going to take and find the derivative of 6. The f prime of 6 is going to be negative 2. And then always our last step is to flip. So negative 1/2. The answer should be A. All right, station 6, we want to find the slope of the tangent line to this function at the point x equals 4. So a little review, taking the derivative of natural log with a function in the inside with that chain rule is going to be u prime over u. U prime, the derivative of the inside is 2 over the original, which is going to be 2x. Simplify, cross off the 2's, it's going to be 1 over x. And we're just going to go ahead and fill in the 4 to get an answer of 1/4. Answer's B. All right, station number 7. As we're looking at station number 7, oh, this one writes it in a different way. All right, as it looks at this one, it's going to say this right here. F of g of x equals x. And what that's saying is these two functions are completely undoing one another to end up getting that x value. So these functions are inverses. And so if those are inverses, then we can go ahead and run through our steps for our inverse function. We're looking for, okay, this step 1 should answer this g of 8 question. And then we want to answer g prime of 8 using our 3 steps. So let's look for g prime of 8, and then we can kind of figure out what else is going to be there. So g prime of 8, so I have 8 is my x value on my inverse, so it's the y value on my function. So I'm going to set 8 equal to f of x. And when I find 8 equal to f of x, I can figure out that my x value is 3. So if my x value is 3, then I know that that would be my y value on my inverse. So g of 8 is 3. So that crosses off a and b right away. Then the next step is to find the derivative and plug in 3. The derivative of f at 3 is going to be 9. And then finally, our last step is to flip. And so we get an answer of 1/9. So my final answer is E. All right, last one. Which of the following statements is true? Well, all 3 of them are talking about, or I'm sorry, all 5 of them are talking about the inverse for each one. So we know it's going to be an inverse statement. Now, when we do our first step normally, every single first step that we have looked at, we always set the x value of the inverse equal to the y value on the function. So if I would be looking at the inverse, I need to use the y value on the function. So I would be looking here, right? H inverse derivative of 5. All right, and so I know I'm going to be looking for that 5 there because that would be the y value on the function, which would be the x value on the inverse. And that cuts off 2 answers for us. So we have A, C, or D left. All right, then our second answer is where we take, second step, I should say, is where we end up taking the derivative and plugging in whatever that new x value is, whatever we solved for. So if I take 3 and I plug it into the derivative, get an answer of 7. And then step number 3 is to always flip that 7. So that would give me 1/7. So this would be my true statement, which the only one that is flipped is D.